Well, hello everyone. This is Miss Link here. We thought we'd do something a little fun, a little different today. We are going to go on a virtual field trip. So, any guesses, any thoughts where we might be going on our virtual field trip today? You may have guessed it based on what you're learning in science right now. You are going to space. All right, so I'm going to be talking and turning and looking around at lots of different stuff. I'll try not to turn too quickly because that can kind of lead to people getting a little motion sickness. But at any point, if you start to get a little queasy because of the way the camera's kind of moving around, just take a little break. You can pause the video, or you can just kind of look away from your screen till you're feeling better and then hop back on. All right, but we're going to kind of explore space today, get excited about learning about what's up there and what's out there in space. I'm going to ask some questions. Your teacher might ask you to pause the video and kind of write your answers down as we go. You might wait till the end to answer all the questions at once, or you might just discuss them as a class. So it kind of depends on your teacher and how they want to run things today. But make sure as you listen, you think about some of these questions that I'm going to be asking about what's up there and what's out there. All right, so let's go ahead and get started on our tour of outer space. As long as humans have lived, we have looked up at the night sky and wondered upon its inexplicable magnitude. Over the centuries, as the sun rose every morning and the moon rose most nights, it seemed obvious that the Earth and the people on it were the center of the universe. All right, now let's look up at this part of the sky. Here we go. As you look up here, you might notice the stars are really packed together in this corner of the sky. It almost looks like a cloud of stars. There are so many stars here. Now, you might have heard the term for this section of the night sky. The ancient Romans called it Via Lactea, which means the Milky Road or the Milk Road. Now, it might sound a little more familiar now. Also, Halloween is coming, so it fits in pretty well. Something you might find in your bag of Halloween candy. It is the Milky Way. So this is our galaxy, the Milky Way. All right, what else do we have up here in the night sky? Ooh. Now, maybe not as bright as if we were looking at the real night sky, but as we zoom in here, we have the moon, our moon. Exciting news about the moon. You might have heard I think just maybe 2 days ago now, 2 or 3 days ago, NASA discovered water in the soil in one of the craters on our moon. So that's very exciting. Very exciting for possibilities about life out there somewhere in the solar system. Also very exciting to scientists because they think maybe now if we decide to build kind of a lunar base, a permanent location on the moon where astronauts could be there permanently or semi-permanently, then they could maybe use that water to kind of do that. And it has really good implications for maybe going even further out into space, maybe on our trip onward to Mars. So it was very exciting news that just happened. It's amazing. We're still learning so much about just our moon, which is so close to us compared to everything else that's out there in the universe. Let's see, what else do we have? Oh, right here, you might notice we have a shooting star. Now, we call them shooting stars because they kind of look like a star. It's a bright, shiny thing flying through the sky. Shooting star is a very appropriate name in some ways. But is it really a star? No, it is not. Stars are very far away. Balls of burning gas very far away. Comets and asteroids And meteors are much closer, and they are balls of ice or balls of rock. So, and they're kind of burning through the sky. So definitely a different thing than a star, but it's fun to call them shooting stars. Another thing to think about, I think you might know this term at this point, but if not, when we look up at all these stars, you might think back to the ancient times and how someone might look up at these stars and notice patterns and think, wow, that shape, that almost looks like a dragon up in the night sky, or a bear, or a hunter. And these different civilizations would come up with stories for these different shapes that they would see up in the night sky. And the term for those different patterns of stars in the sky are constellations. Now, my favorite constellation, I don't see him up here, unfortunately. My favorite constellation is Orion. I love Orion mainly because I find him very easy to spot. Sometimes I have difficulty finding constellations up in the sky when I look up, but I always seem to be able to find Orion. Now, he is easiest to see during the winter. The location of Orion in the night sky, depending on the revolution and rotation of the Earth, he is easiest to see in the winter time. And if you've never seen him before, my tip for you when it is getting colder and it's getting to be winter time, look up if you can see the stars. Might be a cloudy night, but if it's a clear night, look for three bright stars in a straight line, and that is Orion's belt. So that's how you can spot him up in the night sky. All right. So we're going to move to a new scene now. Our next scene, what we're going to really talk about and try and kind of wrap our brains around is just how big the universe is. It's one of those concepts that's really, really, really hard for us to wrap our human brains around. The universe is so enormous. It's like kind of trying to think of how much is in a trillion. It's a really, really, really hard thing to think about and really, really grasp. But we are going to try. That's going to be our goal for the next scene. So hopefully you are ready. We are going to move to our next scene right now. Whoa. And we're gonna look down. Whoa. All right, so like I said, we're gonna think a little bit about just how big the universe is. So let's talk about the universe first. It is thought that the universe began before time and space existed with one big bang 14 billion years ago. This explosion expanded so quickly that in 1 minute, it had grown to the size of 1 million billion miles and was still growing. All right, so we're gonna try, like I said, to think about just how big the universe is. So we're gonna start local. We're gonna start small. Home sweet home. Here's the Earth, right? So when we think about the Earth, we don't think it's small. To us, it's pretty big. Imagine how long it would take us to take a boat and ride around the entire Earth. It is pretty large. But when we think about space, it is so, so, so tiny. So we're going to kind of try and wrap our brains around this today. All right, so here's our Earth. This should hopefully look familiar. Here we have our solar system. Now, this picture of the solar system, it probably looks pretty familiar. A lot of times when you see the solar system in a textbook or in a picture online, it might look something like this, but it's not really accurate. There's a few ways that this is not an accurate photo, it's not a photo at all, an accurate depiction of the solar system. One thing we have to keep in mind is the solar system is really, really, really spread out. Now, everything in this picture is all kind of squished together. And the reason they did that is because they wanted us to be able to see everything all in one picture without it being really, 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 really big. So they kind of squish all the planets close together so that they're a lot closer to the sun than they would be in real life. All right, so that's something important to keep in mind. So let's talk about the solar system and how big it is compared to our little corner of it, the Earth. All right, so think about this. Imagine a pea, a little green pea that you might have on your dinner plate. Picture how small that would be in your hand if you had a single pea. Now, if the Earth were the size of that pea, the solar system would be more than 4 miles wide. So that is how big and spread out, how much space this solar system takes up compared to the Earth. Pretty large compared to the Earth and compared to us on that Earth, as us little humans. All right, now let's keep getting bigger. Oh wait, before we move on, I was talking about how this picture isn't quite accurate. We talked about how it's squished together. But look at this picture. There's a couple other ways where it's not quite accurate. So if you can think of some ideas, you might write those down. Think about, how is this picture of the solar system not accurate? Think about what you know about the planets. Think about what you know about the sun. Think about what you know or what you think you know. And if you can think of anything, write down how this picture isn't quite what the solar system really looks like. All right, let's keep moving. So that's our one star, our star, the sun. What we have here is a star cluster. So we're kind of getting bigger now. We started with Earth, we expanded to the solar system. Now we're expanding to a star cluster. So that's what it sounds like. It's like a group or a cluster of stars. So each one of these stars is kind of its own version of our solar system that we talked about and how big that is. All right, let's keep going. Let's get bigger. Now this might look familiar to many of you. This is the Milky Way, that cloud of stars we saw up in the sky in the last scene. This is our galaxy. The Milky Way is made up of billions of stars, just like our own sun. Our closest star that is not the sun is 25.6 trillion miles away. So really, again, try and think about that. Our next door neighbor to our solar system, that's the next star over, 25.67 trillion with a T miles away. And this Milky Way is made up of billions of those stars. Another kind of exercise, all right? So close your eyes. I want you to think about this. Let's say our galaxy, the Milky Way, was the size of North America. So that means Mexico, that means the United States, that means Canada. If the Milky Way galaxy were that big, our little corner of that galaxy, the solar system, would be the size of a coffee cup. That is how big our galaxy is. All right, let's keep going. Let's get bigger. So here we have a galaxy cluster. The Milky Way is part of a bigger galaxy called the local group. And the local group galaxies are part of an even larger group of galaxy clusters called the Virgo cluster. Millions of galaxy clusters are strung together like an unimaginably gigantic spider web across the universe. The universe we talk about, when we talk about the universe, we usually are really only talking about the observable universe. And what that means is that's parts of the universe that have emitted light that has traveled all the way to Earth. The actual universe is probably a lot bigger. So the only part of the universe that we're able to see is, or observe in any way, is our stars that are close enough that they have sent light out, emitted light, and it has made its way to Earth. There are still stars that have never sent light to our Earth yet. So we wouldn't even be able to observe that they existed, even with the strongest telescope. All right, so the big takeaway here is to really, really think about just how much is out there, how big the universe really is. We only just discovered really exciting news about our moon, which is right next door in the grand scheme of things. So think about how many billions of stars are out there, all those galaxies, all that we have left to explore. It's really kind of amazing to think about. All right, our next scene, we're going to learn a little bit about the life, and I'm going to use finger quotes for that. You can't see it. The life of a star. Now, the reason I used finger quotes when I talked about the life of a star is because stars aren't actually living things, but there's a lot of parallels to the way that things that are alive, they are born. So stars kind of like are born when they're created. They grow and they kind of change the way a living thing might grow and change over its lifespan. And eventually they burn out, which is sort of like the way a living thing might live, grow, and then die. So it's kind of a good comparison, but it's important to remember that they aren't actually living things. But I might say life cycle or the life of a star, but you know what I mean. All right, so let's talk about this life cycle or star cycle. So this is the beginning of a star. This is a cloud of nebulae. Stars are luminous balls of mostly helium and hydrogen gas that start their life as nebulae, or large clouds of dust and plasma. The classification of a star depends on its size and in what stage of its life cycle or star cycle it is. When a star is born from a nebulae, it is called a protostar. As a protostar heats up and contracts, it becomes a main sequence star. These stars emit energy for billions of years, converting hydrogen to helium. Most stars that we see are main sequence stars, meaning that they're in the middle or main sequence of their lives. When the hydrogen runs out, helium moves to the core of the star and causes it to become extremely hot and expand, making it into a red giant. This red giant then sheds its outside layer and cools off, becoming a white dwarf. Finally, when it cools to darkness, it becomes a black dwarf. This is not considered a real star, as we have never been able to see it. So this is more of a theory that scientists have, that stars become black dwarfs at the end of their star cycle. But we've never really been able to observe one to determine whether or not it's definitely true or not. This is based on the evidence that they have available to them. This is what they think happens to stars at the end of their star cycle. So when the star burns out, it runs out of gas and energy, so it's no longer burning, it's no longer sending that light out. And remember, that is how we can see stars. That's how we observe stars, is by seeing that light that makes its way to Earth. So it would be very, very difficult for us to observe a black dwarf once that energy has burned away and burned out. All right, so we've talked about the different stages of the star cycle. All right, we've talked about the cloud of nebulae. We've talked about a protostar, which is sort of like a baby star. We've talked about a main sequence star. We've talked about the red giant. We've talked about a white dwarf and a black dwarf. Now, knowing what we know about these different stages of the star cycle, which of these do you think our star, the sun, is? At what stage of its star cycle is our star, the sun, in? All right, so if you guessed a main sequence star, then you are exactly right. Oops. So our star, the sun, is the closest star to us in the galaxy. A mere 93 million miles away. Now they say it like that, 93 million miles, like it's not very far. It sounds pretty far to me, but when you think about the fact that our next door neighbor, the next star over, is more than 25 trillion miles away, 93 million miles is pretty close. A mere 93 million miles away, the sun has a temperature of 9,932 degrees Fahrenheit at its surface. Whew. And 27 million degrees Fahrenheit at its core. So far, the sun has been around for 4.3 billion years, and it has another 7 billion years to go until it becomes a black dwarf. So it's sort of like the sun's kind of middle-aged. It's a main sequence star. That's kind of the main part of a star's life cycle. So more than half of its life cycle to go before it becomes a black dwarf. So we talked about how big the universe is and how small our solar system is compared to the galaxy or the universe. But it's important to remember the sun is still really, really big compared to the Earth. So one thing I want you to think about is just how big it is compared to Earth. The mass of the sun makes up 99.87% of the mass of our solar system. So what that means is that all the planets, Jupiter, Saturn, Earth, everything, all of their moons, all of the asteroids that are going around the sun, all of that only makes up 0.13% of the mass that is in our solar system. Everything else, 99.87%, is the sun. So that's how big the sun is. It is so big, we could pack 1 million Earths inside of the sun. So what I want you to do right now is I got a little drawing exercise for you. I want you to try and draw the Earth next to the sun to scale. So you're probably gonna want to ignore these pictures because these are kind of showing the planets a little closer to us, a little further away from us. So think about what I was saying when I said how big the sun is compared to the Earth. You're drawing them to scale. Now what that means is we're comparing the size. So draw a picture of the sun and then draw the Earth next to it, comparing their size. All right, it's a challenging question, but I want you to try your best. Try and draw the Earth next to the sun to scale. All right, I have a few more questions that I want you to kind of think about based on what we've been talking about. All right, so both of these questions are kind of things that you could argue both sides. And depending on your evidence, I think both could be considered correct. All right, so thinking about the sun, we've talked about how much closer it is to us compared to other stars. it looks really, really huge, right? But that's really only because it's so much closer to us. It appears larger to us because it is so close. But honestly, it's an average sized star. It might be even a little smaller than average. So, something to keep in mind. So, what I want you to think about is the sun, our star, is it special? All right, I think you could argue absolutely it is special to us. It is very important to us and very special. But you could also argue, no, it isn't special. There is nothing special about it. Depending on your point of view and depending on the evidence you give, I think both of those arguments could be correct. So think about that. Is the sun special? All right, the other question I have for you, I want you to think about how big the universe is, everything we talked about today, what's out there, what we know, what we don't know. The other question I want you to ask yourself is, do you think there is life somewhere else in the universe? All right, there is no definite, as far as I know, no definitive evidence saying yes or no that there is life or there is not life out there. There's a lot we don't know for sure. But you could make an argument for whether you think yes, there is life out there somewhere in the universe, or you might think no. So think about that and give us your reasons. Why do you think yes, there is, or no, there is not life out there somewhere in the universe? All right. Well, that's going to do it for us today. I hope you had fun. I hope you learned a little something. I would love it if you share with your teacher maybe one really, really fun thing you learned today, or one really interesting thing that you didn't know before. You could also share with your teacher maybe somewhere that you would like to go on a virtual field trip. Maybe you have a really, really good idea of somewhere else that we could explore and visit on a virtual field trip together. So be sure to share that with your teacher, or you could even share it with me. All right, I hope you had fun. I hope you are enjoying your space unit, learning all about space. And I hope you have a fabulous day. Thank you so much for joining me. So long.